Good morning, everybody, and welcome to episode 41. Just making sure that everything is running. Yeah, seems to be running okay. Welcome everybody to episode 41 of the MakerBot Chats. My name is Felipe, creative director here at MakerBot, and today we'll be talking about supports. Generally speaking, supports for the method platform. As always, Alejandra's in the back end capturing all of your guys' questions. If you have any questions, make sure to type them on the chat box to your right, I believe, and we'll be answering them as we go. Also, if you're seeing this as a recording, make sure to write those questions in the comment section down below. That way we'll be able to answer them at a later point in time. But for the time being, as I was saying, it's all about supports today. I have a few views, as you can see, my main view here, a few parts here to take you guys through on this sort of side cameras thing that we got going on. And let's start with let's start at the beginning, shall we? And remind ourselves, like, the fact that, as you know, Method is a dual material printer. That essentially means that you will be able to print with two materials at the same time. The material split is meant to allow you to print your component, your part, with, say, material A. In this case, I've got a tough material here for this propeller. And your material B is going to serve as a scaffolding, as a support material for your part. So in this case, I've got PVA here, right? When you're printing an object, and I have this propeller, I think I have it, or when you have an object that needs to be, say, like this one that's a little bit more complex, it has what we call overhangs, right? It has elements that, as you slice that object, from bottom to top, you will need something to hold up the next layer, since it's the layers coming up or coming above any single layer. That means that you will need supports, right? If you imagine here, like these U sections here on this fairly complex geometry, all of these are sort of printing in midair if it had not any support system on it, right? So that means that the printer would be essentially extruding the material on top of nothing. With some materials and with some printers, it's possible to do what we call bridging. Bridging essentially means being able to jump from point A to point B without support, and still not have your material droop as you do so. However, with more complex materials, specifically with ABS, with materials that require higher temperatures, you won't be able to so easily rely on bridging, or essentially be able to print without supports, just because the material will tend to bend a lot, will tend to droop a lot if it's not supported properly. That's why we introduce soluble supports for different types of, for all of our materials, and then the supports themselves come in different flavors. So let's start with that. Just a quick overview of our support system, or essentially our materials first. So I'll go here on our materials page. There's two ways to go into our materials page. If you are in our home page at MakerBot.com, you can just scroll down, and here you'll see a link to the material sections. You can also browse the materials on the nav itself. So here under materials, you'll see that we've grouped them into four main categories: polymers, composites, the metal, and supports. But if you click on materials, just that main title there, you'll go to our main material sections, our main materials page, right? And here you can see all of the materials that we offer, a little bit of an overview of how do they play along with our printers, the extruders, of course, which is another thing that we'll touch on in a second, and then just the compatibility, generally speaking, of the printers versus materials, right? So overall, we have just over 25 approved materials for the method. When I say approved, I want to emphasize the fact that you can now use, and for a while you've been able to use, our experimental extruder that essentially allows you to print with third-party materials, any one that you choose, as long as it's 1.75 millimeters in diameter, right? So you're able to print with any material that you would want to. However, we've tested and tried all of these materials. Some of them are ours, some of them are, for example, like Polylite, like the Polymax. They come from a third party, in this case Polymaker, but we've tested them out. We've developed profiles for them. I'll go, like, for instance, here on the Polylite page, right? And we are telling you what are the best ways or the best settings to use when printing these materials, right? So in the case of Polylite, you can just click here on, download the print profiles. You will get this very, oh, that's weird, why is it, there we go. Comprehensive PDF taking you through all of the third-party materials that we support and letting you know, so in this case, Polylite, what are the settings that you should be using to print with it. So print with the balanced print mode, these are the chamber settings, this is the extruder temperature settings, and any additional steps that you might require in order to print successfully with this material, right? So again, 25 materials just about, and 2 of those are specifically support materials. So if again scrolling or hovering over these material section, you will see that we've got PVA and SR-30 listed as support materials, and I've got them both here. So let me switch my camera view once more. Moving this to the background. Here we go. There you go. And fading here. All right. So I've got a few samples of the materials right here, right? In this case, I've got carbon fiber. So this piece is carbon fiber and SR-30. These other 2 parts are printed out using ABS. This is an attachment for a gripper, a robotic gripper. This is a wishbone out of an automotive assembly. I've got a propeller over here, and finally a bicycle pedal that I printed using also SR-30. So all of these 4 are using SR-30. This one is using PVA. The difference between SR-30 and PVA is that SR-30 is meant to work with our higher temperature polymers as well as some of our composites, right? So in this case, I've got carbon fiber or nylon carbon fiber here, and I'm also using SR-30. And I'll go through the compatibility in just a second, but I want to show you first kind of what are the options that you have when printing with these 2 materials specifically, right? So when using soluble supports, you will be printing your part. I think that this gripper might be a good example. You'll be printing your part out of your main material. In this case, I'm using ABS, and nicely enough, the supports here came out so clean that I can just remove them by hand, so I don't have to dissolve them. And that's something that can happen for some geometries, right? The less complicated the geometry, the easier it will be to remove them mechanically. And what I mean by mechanically, it's essentially just by hand, right? So peeling off the supports as opposed to dissolving it. So the support material is meant to create, as I said before, a scaffolding. Sorry, I'm kind of like losing my tongue today. For your main material, and at the same time provide you with an easy way to remove those supports, right? So in the case of SR-30, this material is soluble. You will need to add an additional element, what we call an EcoWorks tablet to water, to the water that you're using to dissolve the material in order to dissolve it properly. But unlike PVA, SR-30 is going to be much more better equipped or prepared to print at higher temperatures that are required to print with some of our higher temperature polymers, right? So think about ABS, ASA, nylon. Actually not nylon. Polycarbonate would be another one that would not necessarily play nice with PVA, right? So for all of the higher temperature materials, you will want something a little bit more robust. It's not that common, by the way. SR-30 is a proprietary material from Stratasys. That's our partner company, our main sort of the mothership in a way. And they provided us with SR-30, which is a great material for higher temperature polymers, because PVA is just, it's not going to cut it for all of these materials. It's just the temperature that it operates on, it's not enough for you to be able to print it successfully, right? But if you're printing with a, say, less complicated material, like in this case tough, if you're using PLA, then PVA is a great alternative to print soluble supports. And in this case, these supports are 100% water soluble, right? So you don't need to add anything to it. You don't need to change anything on the water. You essentially just dunk your part in the water, wait for a few hours, and you got your cleaned part. I'm going to show you a few videos that we've just released, actually, conveniently enough, on how to make that dissolution happen. So this is actually coming straight up from our support team. So thanks a lot for them, to them, for creating this. But if you go to our, here, let me switch back to our YouTube channel, right? If you go to our main YouTube channel, so that's youtube.com/MakerBot, scroll down a little bit, you'll find this new section called MakerBot Support. And within that section, there's 3 different types of support that you can explore, right? So the one that you might be the most familiar with, Breakaway. Breakaway, I won't play these supports entirely, but Breakaway is essentially creating that same scaffolding, but as you can see here, it's creating the supports out of the same material that the part is going to be made out of, right? So the supports are essentially made of the same exact material. It can be a little bit harder to remove, right? Because the material it's completely fused together, one and the other, and there's no external agent helping you out in removing the supports, right? There's no sort of, water softening the supports or anything that will actually help you enhance the support removal process, right? But you can still use it. It's going to save a lot of time, potentially also some money, right? Because you're using a single material instead of 2 materials, right? But well, that's an option. That's kind of like your standard off-the-shelf option with most of the single-headed printers, so single extruder. Now, PVA, as I was saying here, it's going to be having this sort of yellow-like quality, and they also printed here a propeller. You could, as the video shows, remove or partially remove the PVA supports prior to dissolving your part in water. That's going to save you some time. So if you have something that's fairly clean and separate like this one, where the supports are essentially fairly easy to remove, or like the bulk part of the supports are easy to remove prior to the dissolution process, that's something I would definitely recommend. And then, well, here it is. The part gets dunked in the water. It stays in the water for sometimes it's just stagnant, still water, tap water. And after a few hours, the supports simply dissolve in the water because PVA is essentially, it's very close to what you would know as Elmer's glue, right? It's a polymer that really binds well with water and dissolves in water, so that allows us to very easily remove it from the part. And the third and final part of support, type of support that you could be using is SR-30. So it's one of the ones that I have the more examples of, like here. And the cool thing about SR-30 is, as I said before, is that it's you can see how clean these parts are, right? It's much easier, sorry, keep the camera here. It's much easier to print with, but it does require, additional steps on the dissolution processes, specifically or especially the additive that goes in the water, the EcoWorks tablet, and also highly recommended to have heated wash tank, right? The wash tank is going to also expedite that dissolution process. It is possible to dissolve SR-30 with the EcoWorks tablet without the heated wash tank, but it's definitely going to be more cumbersome and a lengthier process, right? However, for these types of parts, for parts that are using, higher temperature polymers, it's definitely the best option. And it all comes to being able to print, or comes down to being able to print with soluble supports, and that is having the freedom to print any geometry that you want, right? Not being constrained by the material, not being constrained by the process itself, in order to get the results that you might want out of the process, right? I'm going to stop it there, and now I'm going to go back to the compatibility chart, which is another important thing that I want to touch on today, right? We've talked about 3 main materials that you could use as support with the method platform. So let's present this. It might be better to have it as a full screen. PVA, as I mentioned before, SR-30, which is the proprietary Stratasys material that's great for the higher temperature polymers, and Breakaway. Breakaway, the good thing about Breakaway, as I mentioned, is that you could print or you can print the same material in the supports and in the part. That's going to save a lot of time during the printing process, but it can create a more challenging support removal process. So they all come with their sort of set of constraints, set of benefits and downsides. But all in all, PLA will be compatible with PVA and Breakaway. TUF will be compatible with PVA and Breakaway, so that is printing the part itself out of our TUF material and the supports out of the TUF material. PTG only compatible with PVA. That's also true for nylon. Nylon carbon fiber, all of our nylon carbon fiber materials, they are much more flexible when using supports. So that means they can use any one of the three support types that I've discussed so far. They work well with PVA, they work well with SR-30, and they also work with Breakaway. I would say, based on my experience, SR-30 is a great combination for, or a better combination, I would say, for nylon carbon fiber, just because PVA tends to be a little bit more finicky when printing. You really want to make sure that that spool is 100% dry. You want to make sure that you know, the part is not that complex, because sometimes PVA can string a little bit and can contaminate the carbon fiber. So if I had to recommend you one, I would definitely say go for the combination of SR-30 and carbon fiber. It's just going to be a better experience overall. It's a cleaner mix of materials, but you can definitely use also PVA as an option there. And of course, you can use, well, one additional thing that you see here is that you can use SR-30 with a breakaway option. What does that mean? That means that I'm creating, so here you can see how, I'll bring it closer to the camera, but I am printing ABS with SR-30 as breakaway. So that means that I can create that scaffolding that's fairly easy to remove. You can see how it's, you know, much less solid than, for example, here, you know, if you compare these two sets of parts, this part is printing almost a solid element for the supports, right? It's completely enclosed. And in the pedal here on my left-hand side, you'll see that the support itself, it's kind of hollowed out, right? It has all of these perforations. What that's creating, it's essentially trying to diminish the amount of material as much as possible. So create a structure that's very porous, you know, to some extent, that will both allow you to more easily remove the supports by hand if you wanted to do that, and if there's some leftover support still attached to the part, you can still combine it with a soluble system, right? So you have kind of the best of both worlds in that most of the supports, I'll say like 80–90% of them, will be able to be removed by hand just by peeling it or plucking it up away. But for some of these more complex areas, you know, any sort of internal cavities of the part, any more you know, direct or elements of the part that are in contact, directly in contact with the supports themselves, you might want to still use the soluble solution, the wash tank, and remove that leftover, that, you know, final 10%. So you're expediting the dissolution process, and at the same time you're using kind of the more reliable combination of SR-30 plus carbon fiber or ABS, ASA, and PCABS, which is also compatible with SR-30. And finally, for breakaway, you could also use breakaway, as you can see here on the chart, with both ABS and ASA, not with polycarbonate. It's just going to bind itself so well that it's really hard to create breakaway supports with polycarbonate ABS. And, you know, just as a final note here, you know, there's a lot of also, you know, there's elements to consider also when oops, sorry, not sure what happened there. Oh well, here we go. There's a few elements to consider on combining your printers, materials, and models, and extruders, because we have dedicated extruders for the different types of materials. The reason for that is that you really don't want to be mixing up higher temperature materials with low temperature materials. You don't want to be mixing up support materials with you know, model materials, because that contamination can definitely deteriorate your prints, your parts, right? It's better to have dedicated extruders for each of the materials, because you will be getting better results. And we keep going to that same analogy here. Let me fade for a second, but it's similar to a drill bit, right? You have dedicated drill bits for wood, for metal, for concrete even, and mixing them up can both damage your bits and also damage the surface itself, right? If you try to create a hole in the concrete with a wood drill bit, you'll probably end up just damaging the bit itself and not creating a proper hole on the wall, right? It's the same thing with our extruders here. You really want to have dedicated extruders for each materials. Even when I'm using my labs extruder, and I've mentioned this in the past, I like to have, for instance, this one I use specifically for polycarbonates. I like to have a dedicated extruder for each type of material. It keeps things clean, it keeps things easy, and just guarantees that I'm getting the best results out of my prints every time, right? And with that, I'm going to start jumping into the question section of today's chat. So if you have any questions, make sure to type them on to the right-hand side of the screen. And let me get started. Alejandra, by the way, is capturing all of them for us this morning. Here we go. Okay, so are all build materials compatible with all support materials? No, as I said before, the model materials will interact better with certain support materials. So for higher temperature materials, ABS, ASA, polycarbonates, you will want to use SR-30. For more off-the-shelf or let's say lower temperature polymers like PLA, like tough, like nylon, PETG, you will want to use PVA. And then for our composites, that is nylon carbon fiber, you can use either one of them. What is the best support pattern for 3D printing? It depends, right? As I showed you with this part in particular, if you're using, well, if your part is fairly straightforward, I would say like the Breakaway plus soluble is a great option, specifically Breakaway and the SR-30. If you want something a little bit more straightforward and doesn't require that much support, tapered supports is a great option. Also, I think that at some point we will have to do one walkthrough of MakerBot Print. Of course, today we won't have the time, but just selecting the different types of support structures, it's also an interesting thing. Overall, there's three options. There's tapered, there's column, and there's breakaway. Tapered means, and this might be the best example, tapered supports essentially taper upwards to your part, so essentially creating this sort of arrow-like support. So it's not completely flat and extruding the part downwards, but creating this sort of upward pyramid underneath your part. That's also easy to remove. Column support will come straight down as a column, as the name suggests. And finally, breakaway will essentially create these sort of additional elements of maybe let's call it porosity on the supports themselves that should both allow for a better dissolution process and easier removal if you wanted to remove it by hand or mechanically. What support material is best for the smoothest surface finish? It's a good question. I would say it's a combination of my favorite is definitely SR-30 plus our ABS or carbon fiber. It's just the thing is they don't repel each other because they do have to bind to some extent. But you can see here how clean, so clean, so much so that the supports almost like slide out of the part, right? They don't want to bind, they want to bind just enough, right? So SR-30 and the higher temperature polymers, ASA, ABS, great combination. SR-30 and carbon fiber, also a great combination. So yeah, will give you great results overall, specifically talking about surface finish. My soluble material is not sticking very well to the print bed. What is causing this? It could be a combination of issues. I would check that first off that your support material is completely dry. There's also, I would ask you, what's the material that you're using? Are you referring to PVA or SR-30? If you're referring to PVA, I would definitely make sure that the PVA is dry enough. I would check that you could run PVA through our cycle drying routine. There is a routine in the printer. You essentially put your material inside of the printer itself will heat up and will partially remove some of the humidity that might be present on your support. If it's SR-30, I would just make sure, with SR-30, the first layer prior to the support layer is going to be actually a material layer. So this part printed in ABS, the very first layer is actually this raft that prints in the material of the part itself. So this is ABS as well. And on top of that, it's going to be printing my SR-30 material, right? So I would just check that the first layer is coming out appropriately. This is, you can see how clean it is. It was so clean that it sort of, again, just popped out of the part. But yeah, check your calibration on the extruders. Check that the material is not humid or it hasn't absorbed humidity, and give it another go. Are solvents required for support removal? It's not a solvent, it's a tablet, and specifically for SR-30. So the answer is yes for SR-30, and it's essentially, it's very close to a detergent actually, I believe. It's what it's doing, it's changing the pH of the water, and in doing that, essentially allowing for the SR-30 to be dissolved. How do you make breakaway supports easier to remove? Well, that's essentially, part of the geometry itself. So the breakaway supports are going to have these sort of, let me just make sure that you're seeing this on the camera. Yeah, you are. And maybe I can use my macro lens here. So if I bring it closer, right, you can see how these supports are kind of like perforated, like almost like cheese, right, like Gruyere cheese. All of these little holes are doing two things. In this case, since I'm using a SR-30, they are expanding the amount of the surface area that's exposed to the water, so that when I'm running my dissolution process, the water is going to permeate through the supports and in turn remove them faster. But at the same time, with breakaway, these hollowed out elements will sort of reduce or diminish the structural integrity of this part. If you compare it to this one, right, this is essentially a solid, and these are column supports with PVA. But trying to remove this is going to be much more hard, way harder than these ones that are perforated, just because those holes will naturally sort of decrease the strength of the supports and make it easier for me to peel them off with pliers or something similar to that. I'm going to move the lens here. All right. So my PVA prints have these colored marks on the surface. What is causing this? Interesting. I am not sure. One option could be that you're using too high of a temperature when printing PVA. So I've seen PVA in the past that gets sort of these burnt marks. It looks like these brownish or blackish marks on the PVA. That could be causing it. I would also make sure that you clean your extruder, maybe run a purge routine on it. That should help as well. But yeah, make sure that you're using the right temperature when printing PVA, because it's easy to burn it. Like literally, if you print it at too high of a temperature, you're going to be burning the filament itself. What solution is used to dissolve SR-30 support material after printing? I mentioned that before. SR-30 dissolves in water plus our EcoWorks tablets, also available on the store. Is PVA soluble in ethanol? That I am not sure. I wouldn't play with ethanol in the office. I don't know. But PVA is soluble in water. I would definitely stick to water. Ethanol, as you guys might know, it's essentially alcohol, right? It's a type of alcohol. Flammable, that's why I'm laughing. So I would stick to water. The answer is I don't know, but I would definitely wouldn't try it. Stick to water. PVA is a very noble material in that it's going to be very easy to dissolve in water. So yeah. But in any case, that wraps things up. Thank you guys so much for your questions. Always interesting and always great to hear your ideas, your comments. Again, also if you have any comments on future topics or things that you would want to hear more about, definitely let us know. Hello at MakerBot, Felipe at MakerBot at Twitter, at MakerBot Instagram. You guys know where we are. Or, of course, comment section down below. That also helps. And let us know if you have any more questions, if you have anything else that you would want to hear from us. But for now, that's it for today. Thank you guys so much for joining, and we'll see you next time. Have a good one. Bye.